welcome to your tutors AM, and in this video we're going to be looking at simple fractions and partial fractions. So let's say we have got this fraction. Let's say we have got this fraction x minus 2, and then this can be plus, and then here we have minus 1 over x plus 3. So let's say we want to express this as a single fraction. We have to look for the lowest common denominator in which these two values can go into. So the lowest common denominator that these two values can go to is the combined value of them. So we are going to have that, and then we're just going to bring this to our denominators. We're going to have our x minus 2, and then we're going to have our x plus 3. And then now notice that this one is going to multiply that, this negative one is going to multiply that. But let's show it. Let's say x minus 2 into x minus 2 times x plus 3, we're going to get 1 x plus 3. So this one will be multiplying our x plus 3, so we can just say 1, and then we can show that our x plus 3 is being multiplied. And then and then we have x plus 3 into x plus 3, that's 1, and then we have this remaining, which will be multiplied by a negative 1. So we're going to have our negative 1 multiplying that one right there. So I am not going to expand this and have a quadratic, because that would be just wrong. I'm just going to deal with my top part. So once I multiply here, I'm just going to have x plus 3. I'm going to have my x plus 3, and then here I'm going to have my minus x and my plus 2 over x minus 2 x plus 3. So now I have reached this stage. I can collect my like terms. So I'm going to have this will be all equal to, I think, let me clear all this. So I'm going to have, once I evaluate here, I'm going to have x minus x, and then I'm going to have plus 3 plus 2, and then this is all going to be over that x minus 2 x plus 3. So notice that when these x's will cancel, then I will have 5 over x minus 2. Let me just rewrite that properly. I'm going to have my 5 will be over my x minus 2, which will be multiplied by my x plus 3. So have you seen we have managed to express that expression as a single fraction? But what if they want you to come up with the original fractions that created this major fraction? What can you do in that situation? Because we are very used working forward that we never remember to work backwards. So how can we work backwards to our original fraction that gave us this 2? So what I can do to get back to my original fraction, I can express this in form of a, and then since the denominators are multiplying, I'm just going to get 1 over, and then I've decided to get my a and put it over my x minus 2. And then I can say plus my b, and then I can put my b over x plus 3. So now what can I do to get back my values of a and b, so that when I add these two and when I express this as a single fraction, it will get me back to this? What can I do? So initial thoughts of people is just simply, well, what if I put a 2 and a 3 here? Wouldn't that give me a 5? Well, that's wrong, and I'm going to explain why. So if I want to get back to my original two fractions that gave me this, what I'm going to do is that I'm going to make this I'm going to multiply this by that, and then probably I'm going to have something where my a will equal something and my b will equal something. But if you have already seen that, you know that you can't have two variables without solving them simultaneously. That can't work. But never mind that, let's just continue solving. So what I am going to say is that my 5, which is this top part, I'm going to say my 5 should be equal to my a, which will be multiplying my x, which my a will be multiplying this. So I'm just going to say this times that. My a will be multiplying x plus 3, and then I can say the same for my b. So my b will be multiplying that. This is the simplest method to get your values. Of course, there is more solutions rather than getting this directly. This is just the simplest method for beginners. And then I can say my x minus 2. And then now what I can simply do is that I can equate these to 0. So I'm going to have x plus 3 is equal to 0. So I'm going to find my x as a negative 3. So what happens if I replace this whole thing? I make it in form of f of x, then replace my x with a negative 3. What am I going to get? So I can just simply say my f of minus 3 will be equal to 5, which will be equal to a, and then I'm going to have my minus 3 in here, my minus 3 plus 3 plus b minus 3 minus 2. So notice that straight away I'm going to have a 0 here, and then a times 0 is basically a 0. So I can have my 5 being equal to, this is always 0, and then negative 3 and negative 2, that is going to be a negative 5b. And then I can divide both sides by negative 5 and by negative 5. So my b is a negative 1. Now that I've solved for my b, I can solve for my x. Let me erase this part. Let me erase that part. Let me erase this part. Wow, it's not easy erasing everything. Image fill black, and then let me exit that, just one last one, so that everything is clear. Okay, now let me find my value of a. So to find my value of a, I'm going to use this value of b, and then I'm just going to equate that to 0. So I'm going to have my x minus 2 is equal to 0. So I'll find my x as 2. So now that my x is 2, I can just replace, and I can say my f of 2 is equal to 5, which is equal to a 2 plus 3 plus b 2 minus 2. So notice straight away that our b is a 0. So now we're just going to have 5 is equal to 5a over 5 over 5. My a is 1. So you can remember that we made a single fraction. So here basically I have 1 over x minus 2 plus minus 1 over x plus 3. So when I make this into a single fraction, my answer will be that there. And then when I make it as a partial fraction, this is what I get. As a partial fraction, this is my answer right here. So this is our partial fraction. So there'll be a part 2 to the video. But yeah, otherwise this is how we go about it. So thank you for watching. Please like, subscribe, share with friends. This is your tutor ZM. Thank you very much.